Just a couple of things to share today. Continue to do testing, trying to get my Miro board up here. I had previously run some tests, and what this plot represents is, the actual position of the vehicle being here and the goal point being here, and I would expect slight right turn there, and because it's speeding up and getting this goal point stays here for a bit and then it speeds up, the steer angle is getting more extreme until it gets down here really far. These were the angular, well, there's the angular Z again, making a right turn. But it bypassed that point, and then it just, went to crap. And by that I mean, it got close to something, and so I took it out of auto mode. That led me to saying that I wanted to increase there's a threshold when the steering starts focusing on the next point along this path, or creating another point along this path. So that led me to wanting to create that threshold. And then Jeff did some testing, and he had some GPS or lat/lon to X and Y coordinates. And I was wondering if I was having any issues around that. So I spent some time looking at a couple of different methods to create lat/lon. I went out and put some points on my driveway so I could physically measure them and know exactly what the distance was, and then used 3 different ways to convert those lat/lons into X and Y coordinates to measure the distance and be able to compare those. It's a big testing exercise. The end of the story is they're all about the same, so I don't think I have a lat/lon to XY conversion issue. But it was an interesting exercise. I did find the way to have a convert lat/lon to X and Y without using the GeoNav transform. That code is, let's see, where did I put that code? Here's the Slack message that I posted, and that code is over here. So there's a couple, 3 different approaches. One is from this guy that was just doing a search, and I found it on, I think, the Construct, the educational platform for ROS. They referenced this article, and so here's the code replicated. It uses a couple of different functions, and then just the calculation to do the distance. And those average positions, those were, I put marks on the ground and let the GPS sit there for 3 minutes or so, and then averaged those positions. I put code out to take the fix and take some timestamps and average the positions between those timestamps. So that's out there if anybody ever needs it. And then printed the 3 different views of that, which are up here. Meaning, as you can see, distance calculation. I mean, you're getting 100 or so variance in the different calculations. 5.8 versus 5.82 versus 5.86 versus 5.83. And again, a little slightly more variance on the y axis. But that was the analysis that I did. And so then I recreated a mission and ran another test yesterday. Test failed, and I'm going back, need to go back and look at my reference point. I changed the reference point that so the process is drive the tractor out of the garage manually, get it to a point in the grass where it can get RTK, start the launch file from there, and have a known reference point, and then always compare in my data am I starting at that same reference point. So I'm back to testing in the yard with a little bit of sideline of testing different lat long to XY coordinate programs. So that's where I'm at.
So what I was doing this week, I again was playing with the Pure Pursuit, and somewhere like last week, I was playing with. I thought if I could, since the Pure Pursuit works in the simulator just beautifully, I thought I'll try to break that. So I went back, and originally I had a program that I called something like Gazebo to ODOM, and it would go into Gazebo and pull up the ground truth point that is keeps it internally. So it just the absolute point of basically where your base link is, the origin of your vehicle in Gazebo, and in ROS terms, that's base link. So it just pulls up that value, and then it created a the ODOM. So it'd be what ODOM to base link odometry message, and then it would also create the ODOM to base link transform, and it would publish both of those, and that just seemed to work beautifully in the simulator. It would follow along and do what it's supposed to. So I thought, well, the main difference is we are trying to take data from the GPS as opposed to a magical hidden number inside a Gazebo. So what I did was I turned that program off, that converter, and took the code that we always try to use, where we say, take in the GPS, convert that to your XY offset, and then take in a heading, and then from those values you create the odometry message and the transform. I put that in, and first of all, it just failed completely. I can't even remember what happened. And I played with it some more and finally got it so it was running. And one of the things I noticed, I started up, and on the was that a Gazebo on, no, it would have been on the RVIZ. So I had Gazebo running and I had RVIZ running. And on Gazebo, my vehicle sitting where I told it to be, but on RVIZ, it was way off to the left and down from where it should have been. And after playing with that for a while, I realized that if I'd go into my converter and say, if I swap the X and the Y value, and then I think I had to invert the Y value. And when I did, then that put the vehicle in the right spot on the screen. And that had me baffled. And I thought, well, maybe that's what's wrong. So I went out and tried to run that on my vehicle in the yard. And of course it failed miserably, went the wrong direction or whatever. So later I was looking at it, and it turns out we're in Gazebo, we're using the Hector, what's it called? Hector Gazebo GPS plugin. So if you go out and pull up the documentation for that, it says, oh, by the way, we generate our latitude and longitude in a northwest down format, or maybe it's northwest up, whatever it was. That's not something I had heard of before. So that's what the difference is. So the GPS coming out of Gazebo does not match the real world. So you have to modify that after the fact. Now, being in Gazebo, being a simulator, you could probably do things like, say, flip the thing upside down, or you could say rotate it 90 degrees. And then there's probably some variables where you say put in a -1 instead of a 1. It might change the direction on the axes. In the real world, you can't do that. You've got a GPS sitting there. It's got to be pointed up. And it doesn't matter if you rotate it or not. It always puts out the same thing. But in the simulator, you might be able to play tricks there. And just by moving the simulated device around, you might be able to get the output to change. But I haven't experimented with that. And I don't know which makes more sense to actually modify it there or then after the fact in the translator. Just have a thing that says if you're running Gazebo, swap everything. And if you just run the real world, don't swap everything. So that's kind of where I left that. I figured out what the problem was, but still, so back in the simulator now, if I'm taking the simulated GPS and using that as my position, it again runs like it's supposed to and drives around in Peer Pursuit, drives around, stays on the path like it's supposed to. It's not quite as accurate as it should be, but I didn't try to tweak anything on that. So that it's still back to the point where there's something funny going on. The way I and apparently the way Al is trying to run Pure Pursuit in the real world, something is wrong there. And so far, neither one of us have figured out what that is. I was thinking I should just make up a video and go through all the steps here and say, here I'm going to fire up the simulator. I create this bag file, and then you can watch it run in RVIZ, and then go pull a plot juggler, look at all the various numbers, and then go out in my yard and show the thing just driving all over the yard instead of trying to stay on the path. And then, do the same thing, go look at that in RVIZ and look at that with plot juggler, just to show, number one, show the approach of how you do all this stuff. Number two, show the fact that it's not working. And then eventually I can say, oh, we finally fixed it. So now if we, do another video saying this is what you really need to do to fix it. So maybe I'll think about doing that. And I should figure out how to get a video of it. Al took a video of his driving around in the yard when it was working fairly well, and that all worked out. In fact, I'm going to come back to that and ask. But for the moment, if I can figure out how to take a video, I suppose I can take my cell phone out and record it, and it won't necessarily be locked on to where everything else is going on. Or I can just plug a web camera into my laptop on my robot, just have it basically pointed out in front. Maybe that would give me enough of a view of where you're at while it's driving around, and that way you can lock it back to in your bag file. You can pull it up so you have an actual image at any particular time to see what direction the vehicle is pointed and things like that. So those things I thought about doing. And then last night in the middle of the night, I woke up and I started thinking about robots. And one of the big things I notice is if I take a bag file that we've created this way and I play it back, say I said do a ROS bag play, so it's playing the thing back, and I watch it on RVIZ, I can see the transforms representing my vehicle show up on the screen, and there's a transform at the first point of the path, because when you publish a path, it's just an array of poses, and the first one, the first index, and there's the first point you're trying to drive to. And I notice on mine that transform doesn't stay on top of that point like I would expect it to. It's bouncing around all over the screen, and that might be part of my problem. So I thought I could look into that and look to see, see in the code what they're doing with that, because it looks like the way this thing works, you subscribe to the odometry topic, but they don't actually use anything out of the odometry message. So the first thing they do when you get an odometry callback, they say, go out to your transform tree and tell me the difference between map and baselink. And that accounts for anything in between there. Say if you run an AMCL and your odometry marker is moving around, that method takes into account everything from your map at 0, out to your baselink, wherever it is now. So I think that's why they did that. So you run that and say, give me the transform. And that says you are at this XY position on the face of the earth and you're pointed this direction. So they come up with that first. And then the next thing they do, they say, tell me the transform between the target point, which is that first point on our path, and baselink, which is the vehicle. And when you do that, it gives you back information in the robot parameter, what do you call it? Parameter frame, the robot coordinate frame. So it says out the front of the vehicle, this is your X distance out to the target. And then out either the left or the right side, it says this is how far, if we were to extend that center line of the robot. So, you look at the robot, pull out my right hand rule here. And, looking forward is the X. Looking forward is the X direction. If we just extend that line out. So the question is, how far, as that line passes our target, how far from that line to the target is it? And that's what they call the off path error. So basically this thing is swinging back and forth. Here's the target point here. As the thing swings back and forth, you pointed right at it, then you're going to get an off path error of 0. And if you're over here, it's going to give you like 3 meters, and here it might give you like -2 meters or whatever it is. So that's what that's trying to tell you. And then the third thing in that transform is the rotation. So it basically looks like it's just taking the difference between your vehicle, which my vehicle was pointed north, which is 1.57, and my first path point was pointed west, which is 3.14. So it just takes the difference and says the difference between those two is 1.57. So taking all that stuff together, it says that's from the vehicle out to the point. That's where the thing is represented by X, Y, theta that it returned to us. And then I think the next thing they do is they take those values and they create a new transform called the lookahead transform. And that's when I was laying in bed thinking about that, I want to see how they do that. And did they just simply take the numbers we gave it and create the new transform? Because I say on the screen, say I've got a point. Let me do this view, speaker view. So say we got a point up here and my vehicle's sitting over here. And I forgot the point I was going to make. Blah, 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 blah. Oh, the fact that so this point up here is the point we're trying to drive to, and I would expect the transform to be right on top of that point, but it's not. It's like over here, and it's bouncing around like this as the thing's moving. So I would think if they just take the value from here down to our vehicle here, and just create the new transform, it should be right on top of that one, but it's not. So I decide that's either possibly if the heading is noisy, then you're going to have like an arc. It'd be the other direction. Anyway, so let's assume the vehicle's down here, and if the heading's noisy, you're going to have like an arc that comes around like this. It's still backwards. So anyway, it would be the point that's moving on would be on an arc, and then if our XY values coming out of GPS are noisy, it's just going to keep randomly bouncing around like this, and it's probably a combination of those two, if that's what's causing that. Otherwise, there might be something funny in the code that's making it do that. And that's why I need to go look at the code and see what the point of creating that transform, that look ahead transform is, why they're doing that. Because they fall through the next step that either takes the point on the path or it takes that look ahead transform. And then from one of those, it generates the new steering angle for the vehicle. So I just want to see which one is it actually based on there. If it's based on the one that's jumping all over the place, that could be problems. But if it's based on the actual point on the path, then that should remain stable. And the odd thing is, if I run this on the simulator, which has perfect positioning, I don't have a noisy GPS on that. You can make the GPS noisy, but I specifically turned that off, so it wasn't causing problems. And if I run it there, that transform marker that it creates stays right on the path. So it goes click, 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 click. It stays right on the line as it's moving. So there's something odd going on there. I just need to, I need to go track that down and figure out what's happening there. And let's say beyond that, so if I take it out in the yard and run it, I seem to have one of two things that will happen. I go out there and I line it up, say, okay, I'm right where I need to be, start up everything, and I say go. I flip the switch to auto mode, and then Pure Pursuit starts controlling the steering. And if I have a noisy heading coming in, say if I'm taking the heading for my single GPS, when you're not moving, that's just a noisy signal. It's bouncing around, and you can watch the actual wheels. Will start doing this. They'll start wiggling back and forth a little bit, and then as soon as I start moving forward, then it'll calm down and start following the path. Now, some of the times when I run it, the thing turns the wrong direction. It turns to the right. It starts going east when it's supposed to be going west. And then if I get all the stuff coordinated to the point where I have the right heading coming in, then it will attempt to turn and it'll turn and go to the west. But it doesn't seem to, the way it's set up right now, it doesn't seem to understand where the path is. It just keeps making big loops and circles, but it is actually trying to control. So that's better than when it doesn't work at all. So that's kind of where I'm at on that. I've done various runs, and I like the thing Al was just showing, where he showed that he had a green line and an orange line saying, well, he's right here. It should be smart enough to do a small turn and hit that point that he's showing right there. So it just seems like, pick a point. I came up with three things you could test for or think about So I have this path that runs, like in Al's case, it runs north and south, and then your vehicle is sitting down here somewhere. You could put your vehicle on the same line, just physically come down, extend this line down, put your vehicle here and point it up. So it's pointed right on the path. And then go look at the numbers on that. And it should say that you have an X distance of 2 or 3 meters, whatever you are away. And it should say your off path error should be 0. If pointed directly at it, it'll say off path error 0. And then the return heading on that should say, I think it's going to say 0 because it's the difference between the two. So that's one case right there. Those should come out and say, yeah, you're pointed right at it. Everybody's happy. So another case is you can just move it over here parallel to the line. And then again, you're getting an X distance. Now your off path error is going to be whatever amount you moved it. Say you move it to the left, it's going to say, if I moved over 1 meter, it should say 1 meter. And then the angle will be whatever the difference of angle will be. No, actually, I think the angle should also be 0, because if this thing is still pointed straight up and the point is over here, I think that it should say the angle is 0 because both headings are the same on those 2 points. So that would be another thing you could check. It almost seems like if you go out in the yard, and Al's going to have a hard time doing this, but I could do it easier if I put my vehicle, like in that first case where I know where my path point is, so I'd have to mark it somehow, put my vehicle like 2 or 3 meters in front of where the path starts, and I start the thing up. I should just be able to pick up the front of my vehicle and pull it one direction or the other. And as I do, I should be able to watch the wheels should steer towards the point as I do that, without moving or anything. That should just magically, if everything's working like I think it should, all I got to do is when I put it on, it's pointed right at it and say go, the wheels are going to be pointed like this because it's pointed at it. But if I grab the front of the vehicle and turn it, then see if I move the vehicle this way, then the tires should steer to still be pointing at the destination point. And it almost looks like the thing is just simply oversteering. And so when you try to do anything, as Al says, it starts just getting bigger and bigger. And mine would go into like a full left, and then it would seem like it would drive drive halfway around the circle, and then it decide to do something else, and the wheels would turn the other direction and drive another halfway around the circle. So it's almost like maybe when the sign of the steering angle is changing or something, it's affecting it. But that's just more, maybe just gonna be a matter of going out and playing with it and trying to observe that. Or if you run these tests, so the third thing so the first thing is, point it straight up, and here's your point up here, and here's your vehicle down here right on line. And the other thing is move the vehicle over like this. And then what was the other thing I was thinking? I think maybe do that and then turn it to the point. So you're off the path, and just go look, because for each one of those cases, you should be able to look at the numbers and say, this is how much steering angle that should create. And whether it's, whether you come up with an exact number or something that's, if it says, oh, I'm going to turn as hard as I can to the right to correct for that, that's probably not what it should be doing. But you should be able to just go through that and say, under the circumstance, what it should be. And then you look through the different calculations and see how it generates that steer angle, and see which value coming into that is confusing the thing. So that might be another way to approach that. So and the only other thing I noticed was, or that I played with, I went to all my code that I've got. I've generated a heading in lots of different methods. So I've got my BNO085 IMU, and it will generate an actual heading that seems to be stable. And I was trying to get that to be in ROS compatible, so it's ENU format. And so when you point east, it says 0, and then as you turn counterclockwise, the number increases, which both of those are different than the way a normal GPS or a normal compass works. A regular compass, you pull out of your pocket, it points north, which is 0 degrees. And if you turn clockwise, then it starts increasing until you're pointing east, and it says 90 degrees. So both of those things are different than, the ROS format of ENU is different than everything else. I'm still not sure why they picked that or why they use that. But anyway, I played with my IMU to get it to do that. And was the other thing on that IMU? And I noticed the last thing I ran last night, I took it out and drove it. And I noticed this a few days ago when I first tested it, that as I drive around, my IMU seems to be 185 degrees off from where it should be. And I think the 180 comes from the fact I've simply got it bolted on the machine backwards. So if I wanted to, I could take out 2 screws and rotate that around. Unfortunately, then the USB cable's in the way. So I'll probably just try to subtract off this value. And, I can say subtract 180 and get it back to approximately where it should be. And that extra 5 degrees, I don't know if that's my magnetic declination or if it's just simply I didn't bother to, to twist it on there and line it up exactly with the right angle. So I'll probably just go in and say the next step, I'll probably just go in and say, on top of everything else, just blatantly subtract off 185 degrees and try to get it so it's, when I'm pointing to east, it says 0. And that's what I'm going to do on that, which then brought up the fact all of these other headings I have, I've never gone to the trouble to get them all in the same format and get them all ROS compatible E and U coming out of them. So I should just go down the line for anything I have, which right now I have the static heading from my second GPS, and that needs to be modified. And I can get just the standard heading from a single GPS, which when you come to a stop, it's noisy, but I figured out a way to latch that if I wanted to. So that's another heading I can get. And then I've got the heading from the IMU. And if I had the wheel odometry working right now, both of my back tires are flat. They're pneumatic tires. One of them's flat, so it's low, and then it's flat enough. It's actually popped off the rim and flopping around. So my wheel odometry doesn't work at all right now. I need to, if I just put air on the tires and tweak a little bit, I could get something on that. But that'll put out a heading, but it drifts so bad it's probably not usable in the long run. Once somebody pulls up robot localization and feeds the odometry and the IMU into a Kalman filter, then it will be useful data and you can do something with that. But for right now, the whole point right now is trying to take an absolute position from a GPS and an absolute heading from an IMU or something else and merge those together to say you are here and feed that into the pure pursuit. So you got to get that stuff working first before you put it into the Kalman filter, because I'm sure a Kalman filter can do absolute magic, but if you put it in garbage, that's not going to help you out. So you got to at least figure out on each sensor what it should be doing and try to get it as close as possible before you move on to the next step there. So that's kind of where I'm at right now. I need to go through all of my sensors and get them all figured out and get them all producing the right type of output so I can just swap one to the other, at a moment's notice. The other thing I noticed right now, my code that's doing that, I have 3 different formats of heading coming in, because if you subscribe to the IMU, well, the IMU puts out a block of data that says here's your acceleration, here's your rotational velocity, and here's your orientation. And maybe there's something more in that. So that's one format you have to account for. And then if I take in data from so what are my other sources? I think for my static heading for my dual GPS just puts out a single number that says, this is your angle from wherever. And then I thought I had, the other format is there's something that's being published on just called heading. So it's a / heading topic. And that's actually as a quaternion. And I think that got generated. I think Matt went into the NEMA NavSat driver and just added a line there that says, take our heading we've got and publish that as this quaternion. And to account for that, I think I went into my stuff and I created a node that says subscribe to the GPS/vel message. That's the other message that the NEMA NavSat driver puts out, or in my case, is being put out by a different driver. But you can take that value, which is that's a velocity vector. So it says here's your velocity in the X direction, and here's your velocity in the Y direction. And if you take those 2 values and manipulate those, if you take I think it's like the tangent of Y over X, will give you it'll extract the heading out of that. And if you do the square root of X squared plus Y squared, it extracts the velocity in meters per second back out of that. So once you get the velocity on the angle, you can just publish that as whatever you want to do. And then while you've got those right there in front of you, you can say, if the speed is over some arbitrary value, like say 0.1 meters per second, then we'll update the heading. And if not, we just won't update it, which means it'll latch it. So when you come to a stop, it'll take whatever value you had as you're coming to a stop and hold that and keep publishing that while you're sitting there. As soon as you start moving again, as soon as you get above the speed, then it starts updating that heading again. So I've got a node that does that. And I just need to, again, take all these different nodes and make sure they're outputting the data in the right format. So anyway, that's the one. That's how I created that that heading quaternion. I extracted the data off the GPS, so it'd be off a single GPS. So that's what anybody would have. And that gives me a heading and a speed. And then if I want to, I can latch that heading so it's not, so it would be a valid heading when you're at a stop. And then I was publishing that as that heading quaternion. So inside my code, I've got one thing that'll a type message for an IMU, another one's just a blatant angle coming in, just as like a float 32 or float 64 or whatever that was. And then the third option is this heading quaternion that's coming in. So I just go in my code. I left all three callbacks there. It's just when you say subscribe, you comment out all the lines except the one you want to use. So if I want to use the IMU, I uncomment the one that says IMU pub, type quaternion. No, it's gonna be type IMU, and then you give it whatever the topic name is, and that'll call the appropriate callback down below. And then if I have just an angle coming in, which I have several things that generate an angle, again, you just uncomment that line that says something like angle pub, and then it says type float, say float 32, and here's the topic we want to use, and it calls the appropriate callback. So just by switching which thing I subscribe to, that lets me switch between those. And eventually I should put parameters on, say, here's a parameter that says use this type of input, so I don't have to go keep hacking on the code every time I make changes here. But so far I'm still in the hack and slash mode, and we'll see how far that gets. And one other comment I wanted to make, I was just looking at, because somewhere along the line I was plotting all of my different headings to see which ones are correct and which ones are need fixed or rotated or whatever. And I just had this one up on the screen here, and I realized it was the, I have one is the static heading for my dual GPS, and the other one is that slash heading message I was just talking about, which would be the heading for the single GPS. And as I was saying before, when I play this back on RVIZ, my look ahead marker keeps bouncing around on the screen. I thought, well, it's either a noisy heading or a noisy GPS. And I thought, well, let me look at it on the screen here. So I zoomed in on a section, and sure enough, it does. It's one of them is bouncing around like 0.1 meters or something. That's the one that's coming out of the single GPS. So I get something on the screen. I get this jagged thing that looks like this. But the other thing I noticed was I had that plotted on the top of my static GPS, and that one has it's a fairly smooth curve. It's got a little bit of jaggedness to it, but it's a lot less noisy than the one coming out of the single GPS. So that's just another other observation I made since I was in looking at these plots anyway. And another problem with that static GPS, I got the point I trusted that completely. No matter what I did, I'd take it out, fire it up. It said I had a fix on both, a fix on the RTK GPS and a fix on the moving baseline GPS, that I could trust it. But I took it out one day and ran it, and it turns out I got all done. And it turns out the heading was wrong on that. I'm not sure why. So I'm going to stop trusting it completely at this point. But that's where I could want to be able to switch. I could say either switch for my static heading, or switch for my IMU, or switch for my single GPS heading, or whatever. That's why I want to be able to easily switch those back and forth to see what I can do with that. So other than that, I guess that's kind of where I'm at and kind of what I want to do. And I've got in my mind, I've got these steps that I need to do. I should write this down so I don't wake up at 3:30 in the morning and go through all this in my head again in the middle of the night. So we'll see what happens with that. So I'm gonna say that's all I got to say for now.
Before I come back to that, just something to share. When you get into that pure pursuit program, this is the data that I put out in a multi, whatever they call that, a multi-factor array. And if you ever want to pull this over, it's there. I was getting multiple look. You're going to find that there's 2 or 3 different objects in that code. And I was getting a pose position. There's a transform that has the current position. along with the rotation, and there's, as you mentioned, the look ahead transform. And I had question marks there trying to figure out whether that was the distance and heading to get to the goal or not. I don't know if I ever resolved that. But that's the data that seemed to be important in those 2 or 3 different objects in that Larry's pure pursuit code. Let's see. I also know got a email alert about Sparkfun has BNO086 out now. It's made by these guys. Not that we need another IMU, but just thought I would pass that along. Bear with me while I take care of a dog who wants to get outside. I don't know if you can hear that racket or not.
Yeah, I can hear him. I pretty much decided I'm done chasing buying new IMU boards until I at least get things figured out. And for whatever reason, the BNO88, the BNO55 that I have works great if I don't calibrate it. And then the BNO85, it won't work unless you do calibrate it. But when I calibrate, it keeps dropping back out. So I'm still going to that BNO55. That seems to be, I'm happy with that for the moment until, well, if Al buys one of these new ones, we'll find out how well it works.
I am not buying a new one. I have enough headaches. Not trying to.
So a couple of, since we're on this, I'll make another comment here. You're saying the one you're using now doesn't give you something. I think you said it doesn't give you rotational velocity directly, or there's something about what it outputs doesn't give you everything you need. Well, then let's go back to your comment. You got a whole box of IMUs laying around. Just go grab another random one that does give what you want and put 2 of them on the vehicle. So you can pull up, certain values from one and then certain values from the other one. You can pick and choose then whatever you want to use on that. Because I know you're saying the one you have now for some reason doesn't it doesn't give you an absolute heading, it's just a relative heading. And then I thought you were saying that one doesn't give you a rotational velocity directly out of it or something. So you just pick a different one that does have the values you want and just put them both on and run them at the same time.
Yeah, I don't remember about the rotational velocity. If I go into, let's see if I can pull up some code here. Share my screen. If I go into I basically have heading from 2 sources, the GPS and the IMU. And it's this. Although I guess I could get heading from the wheels. I've never done that. I ended up in the calculation just trying to get down to it. I keep track of both of them, but when it comes time to get serious, I've got a variable that I just named yaw being used, and I either use, you can see the commented out one now is the one that comes from the GPS. The one that I'm using is the one that comes from the IMU. That's just the way that I've resolved it. So code below is going to use this variable. All the code above is keeping track of both of them, but when it gets down to here, that's the one I'm using, and at the moment it's the IMU one. Now that one does require me to set what's the yaw at when it's first fired up, because as you said or alluded to, it doesn't have a magnetometer that points to north. It has a magnetometer that says this is how much change I've seen since I last started up. Because it always starts up at 0, no matter which way you point it. And it's a Bosch BNO086. And it's on a board that was put out by a company called Chip Robotics. But anyway, I don't, at the moment, I'm not thinking I have a problem with yaw. I think I have, well, to get that Larix thing fixed, I don't know what it's going to take to fix that pure pursuit calculation. I'm somewhere in the transform, one of the 2 transforms that it uses. We're doing something, I'm doing something. Again, back to why is it work in simulation, not in the real world? But yeah, just gonna have to keep testing.
So the other thing I remembered was when I would go out and run my stuff in the yard, and let's see, was it? Yeah, when I went out and ran it in the yard, I came back and plotted it out with Plot Juggler. I noticed when it plotted the path, my path was hacked up for some reason. It's supposed to be going around, have a loop at both ends, and one of them it chopped off like a third of the loop was gone. At the other end, it threw out most of the loop completely. I just wondered, have you ever seen that do that, or do yours work every time? And I'll tell you what that is. That's when you plot the look ahead 0 and 1 points. That's your internally, you said when the path comes in, store that into that array, and that's what it's plotting on the screen. And for some reason, as I say, when I plot them out, they seem to be wrong. And I think it's actually, I think the array that I'm seeing is actually wrong. So I don't know. I was curious, have you ever seen that? And I didn't know how internally you're copying that array, the incoming data to that array you're putting out.
So have I seen it? I think so, but my recollection is whenever I saw partial data, it was because I switched it to manual mode and then drove away. And I'm sort of thinking it stopped trying to calculate it because it was just, it kept that look ahead point no matter where I drove. So I think for me, it was linked to switching to manual mode because I got in some trouble and didn't want to hit something or knew that it was going to fail. And the look ahead point stayed. I never got close enough to that look ahead point to generate another look ahead point.
So do you create that path output point by point, or do you do it as soon as the path message comes in, you just copy the entire thing into that look ahead 0 and 1 array?
I think I'm doing it what you would describe as point by point. If I go look at I for one don't create it. It's created in this I only replicate it in my arrays. So if can I get all the way down to the bottom of this quickly?
Yeah, so that's my current question. How are you replicating that? I assumed that as soon as the path came in, you just copied the entire path into this thing, but maybe that's not what you're doing.
Yeah, this is the informational data that I'm pushing onto the array. How do I get rid of it? I can't get rid of it's hidden. There we go. So this, array that I'm publishing, I'm just taking whatever data is available at that particular moment. And this is um, these are the vectors, or these are the objects that get created by this thing. So I'm not doing anything with the data, and it just, as this command is executed, it's creating the data. I mean, there's a couple of them here. This kinematics dynamic library thing.
Okay, that gives me the idea. Then I assumed you were just copying the whole thing as it came in, but if you're not, you're doing it point by point. That gives me a different place to look at there. So apparently, when I was driving around that time, it did something funny, and it skipped from one side of the loop to the other is what happened there. So
Yeah, hold on a second. I'll be right back. Let me get this crazy dog. So, I mean, this is that, the copy of the Pure Pursuit program, and these are just, I believe that's the current position. I'm sort of thinking this is the object that holds the look ahead data, and you get the XYZ plus the rotation. And I wanted to see what those commands or those values were as well. And so I'm just pushing out those, what is it, three, a couple of data points, or between 2 and 5 data points for each of those objects.
okay. And before you leave this program, I'll make another comment. We done talking about that?
Yeah, go ahead.
At one point you asked where is the source code for, they said something about create transform to baselink or something. And it turns out the source code is right here in this program. Because there's at the top, there's something that says something about the convert to baselink that I believe is the function prototype. And then down here in the code is they basically have the function is right here in the code. It's just that because it's object oriented, I didn't realize at the time that's what they were doing.
Well,
So right there, transform to baselink. Now that right there is, that I believe is the function prototype. And now if you search for transform to baselink, there is actual code down below that's doing this transform. Right there, I believe. I believe that. So this is the function called transform to baselink, and then down below is code for it. So it's not. I was out looking all over the internet trying to find this, but it turns out no, this is just a function they made up and put it right here. And I don't know how any of that KDL stuff works. So
you think this function starts on row, in my case, 369, and goes to where?
go down a couple more lines.
Well, here's a return function here.
Well, I think the line below that is the last line of the function, I think. Yeah, so 394, that forms the function of transform to baselink.
You're a better programmer than me, so if you say so, I'm going to believe it.
Well, that's the only thing I can figure out. So when I went through that whole, I went out to KDL and looked under frame, and there nowhere did they define this transform to baselink. So I think this is defining the function right here. Is what that's doing. And knowing that, then if I were to look at the KDL statements they're doing there, maybe that would tell me, maybe I could figure out what they're doing there too. So. But it's just something that, again, I think it was in the middle of the night that occurred to me that, oh, that's what that is. So I just want to mention that.
Yeah, thanks for that, because I can't say that I've come across, KDL statements and didn't know the syntax, and seeing these inside of that one sort of made my head spin. Hey, and there's a spin statement.
So the next thing I wanted to do was, go look at this code, and it says, here's the next pose in the array. And then they create a transform between that and baselink. And then my question is, did they just take those values and then create the next transform called lookahead transform directly from that? Or is there something else going on in between there? And then if there's something, when they go to do the actual steering calculation, I just want to figure out which one of those two sets of data they're using. So that's kind of where I want to go with it right now.
Yeah, I've commented out the Angular Z stuff, but I was using it to get down to I think this, my recollection is correct. In two different places.
While you're right on that line right there, is that two duplicate lines? See the line right above 280. Should 280 be commented out? You just write over it with line 281, but it looks like line 280 isn't actually doing anything. It just seems like that line should have been commented out.
I would agree with you. I'm not sure why they're both active.
You probably just forgot. So it's going to take the second one that's there, and maybe that's a problem. Nah, I don't know.
I don't know. It would be interesting to see which one you're using. I obviously made a note here, but that was the original one. But I think this is calculated in two different places. And I just do it I did it in three just to be safe. Shoot, let's find where the other one is. Oh, come on, don't be a pain.
Well, it's just simply you took that first line and broke it up because you didn't like that min function. So you just decided you're going to calculate the value, and then below you just check. You're doing your own check for min and max is all you're doing.
Exactly.
But anyway, every time I looked at it, I kept thinking that looks like that's duplicate lines for some reason. So now you're confirming it is. So
Because I added lines 282 through 285, as you can see.
yeah.
And why won't that do a find on that? So let's just do it this way.
Are you in GitHub? GitHub has a problem with doing finds, and I can't remember. Something about the characters used that says, "Oh, I don't understand those characters," and just refuses to work.
So there, populate message with static data, delta. No, maybe it's just one. I thought it was two different places. I don't think that's running on time. It's in the object. Yeah, I guess that's the only place where it's calculated. And so what I had, it's taking this look ahead distance that it squared plus this, that's a constant. And this was the only thing that, varied over time. So
Well, that actually, I believe L is your wheelbase, and I believe YT is your off path error, which is calculated.
Thank you.
And I think those come, and then LD2, I think is LD squared is what it is. And
yes.
So it looks like, without, that very first time they say, give me the transform between the target point and baselink, that's where that YT comes from, I think. So it seems like a lot of extra stuff going on here is not even being used. So I need now we talked about this. I need to dig through that and see what's actually happening there.
Well, I think we can turn off recording now.
Well, I was gonna say we consider for a few seconds. I tried putting an end screen on the videos, and I was able to do it last week. And the week before that, it came up and said, "Oh, your video's in the wrong aspect ratio." So I looked up aspect ratio and this problem, and it said, "Oh, here's how you fix it." And I said, "I don't have the ambition to do that." So I may put an end screen on this one, so it'll put that the lower left hand corner, and it'll say, "Here's the subscribe button that takes you to the web page," and on the right it says, "Here's a random video you can watch." And they will put it over the top of people sitting here, but that really doesn't matter, I guess. So I just as a point, I thought I'd note that, and I realize now it doesn't really matter, because unless somebody's actually holding something, said, "Oh, here's what we need to do," and then if it writes over the top of that, it'd be a problem. But just two talking heads sitting here babbling on, and people don't need to see that anyway. So I'm going to stop it now.